to measure with the S and M units to measure the straightness of your shafts. So you can use either the S unit as your laser or the dedicated line bore laser as your laser for this application. So in this case I am using the S unit itself as the laser, and the M unit will behave like a detector. Okay, so the first step is to go and make our reference line. So now you can imagine this as your shaft. Okay, so now start new. I'm inside the program, and then the detectors are connected, so I'm going inside the program. So now I can open up the M unit. I go as close as possible. That's in your first position. Mark that position. So you have to make sure, because you will be here, it's a plane surface, whereas the shaft will be a rounded surface, so you'll have to make sure that it is staying 0 degrees all the time. Okay, so now I see the M unit, zoom it, so you can just press 0. That's my first 0 position. So now I go to the last end of the shaft. Okay, so which is your last position that you need to measure. You go there, and you can see that the laser is not hitting on the detector surface, so the laser is hitting somewhere down. So I have adjustment screws on the laser, so I can move it up and down and sideways as well. So I just go up and go to the detector surface. So you can see that the detector is coming to the, in the detector you can see the laser coming to the 0 level, so you can make it to 0. Okay, so you don't need to worry about the horizontal, because the horizontal is only in this direction, it is not required. We only care about the vertical, and you can be as close to the center. So now we have a 0 here and a 0 here, so we'll have to redo this step 2 times so that you have a perfect 0 0. Okay, so now again 0 when you're close, and then when you're far away you adjust and bring it to, so now the laser is inside the center of the detector itself. So now I go and adjust and bring it to 0. A little bit. Oh. Okay, so now when I come closer, you will see that it is 0 0. 0.02. Good enough. So now our straight line is set, so you can go and document the results. So you can go to the straightness, start new. So how many points you want to measure in this shaft, you can give it. So number of positions, so you can put it as 5 or 6 or 10, whatever it is. So start position, you can put it as 0, and the end position, so what is the distances that you're going to measure. So let's say if it's a 2-meter shaft, then you can put it as 2 meters. So let's say 2 meter, and then it will automatically calculate the interval. But if you want to have different intervals, then you can also go and change the settings. In your settings you can go and change the values of the distances, whatever the distances are. So now we go for the measurement. So I'll switch it on. So now we go for the measurements. So you can go and detector. So I'll just laser is yes, detector is M unit. Okay, so now we go and we can start our measurements. Okay, so the first step, we go closer, enter. Second one, so let's say after 500 mm, enter. Third one, enter. The fourth one. So you you go at different positions, and the last one is our reference point. Enter. Okay. So now all the measurements are done, so we can go for our report. So you can see the values, so you can go to the reference setting, and the first point and the last point is our reference, so you can see the table now. So with respect to the line, so it's going a little bit down like this, so you can see the graph as well. So we don't use the horizontal graph, we see only the vertical graph. Okay, so you can see the table, so it's 0.38 down, 0.69 down, 0.38, 0. Okay, and then you can make a report and your measurement is done. So if you're going to, this is the straightness, but if you're going for the run out of the shaft, so then you can measure in all the 4 quadrants, and